Charging is on. Still I will check the charging. Sometimes what I already checked it. Still doubt. Okay. Oh, yes, on. Voice, display, etc. Everything clear. I decided to use the full board now. Upper side, lower side, lit other things. Some you can see some mark here that I will remove late next week. I'll put some covering here. But actually full board is useful for me because so many calculations are there. Laptop it will be full. Display is okay. Tell me. Display is okay. Clear? Okay. Now start. Remember now, bending stress distribution you are covering. Oh, sorry, mic I cannot put. Yes, mic is there. Now, see, last time question, I have given cross section for you. See, now, today's class and tomorrow's class is very, very important to thoroughly understand the bending stress distribution for beam. So many principles I tell here is required for RCC, but I won't mention RCC here. RCC or any beam for that matter. Even steel beam also. See, steel beam. Sometimes what happens is, if it is laterally supported, IS code permits top fiber stress and bottom fiber stress both equal to Fy by 1.1, Fy by gamma MO. Gamma MO is 1.1. That all you worry in steel. But even there, suppose you add one flange plate to one side, then section becomes unsymmetrical. So therefore, theory is required. But if the beam is laterally unsupported, then anybody can tell where weakness comes. If the beam is, see, when bending takes place, compression, tension, both are coming. If the beam is laterally unsupported, anybody can tell where weakness comes, compression side or tension side. If beam is laterally unsupported, later when I take steel structures class, what I will do is, see, when I take a steel class, I will tell at that time, to understand all these, you go back, go to YouTube, because usually in the steel, I tell all those things. What happens because of lateral, I will tell at that time. But why it is that way, that I can tell now. Go to YouTube, go to that bending stress and shear stress. Class number you search and go through it. It will give you a complete idea. Tell me, where? If it is laterally unsupported, tell where weakness comes. See, when bending takes place, one side compression, one side tension. One extreme fiber compressive stress, other extreme fiber tensile stress, maximum. Sagging means top compression, bottom tension. Suppose cantilever, hogging, top tension, bottom compression. That's all okay. But if it is laterally unsupported, where weakness comes? Tension side or compression side? If you don't know, tell don't know. If you don't know, tell don't know. No, sorry. It is not tension side. It is on compression side. Because if the beam is laterally unsupported, it can undergo lateral bending, or compression flange is likely to something like a buckling. Correct? So, tension side, no problem. See, tension side, there is no buckling on tension side. Compression side, it becomes weaker. Therefore, IS code at that time will tell your bending strength MD equal to, see, usually it will tell Fy by gamma MO into ZP. If you consider plastic, if you consider elastic, Fy by gamma MO into Z into 1.2, that all comes in steel. That means IS code is not bothered whether tension or compression side, both are equal strength. But if the beam is laterally unsupported, those who came to steel will be knowing it. It is your MD equal to FCD will come. FCD is the allowed stress in compression. They are not going for tension. Why? They know that compression side safe means tension is little over safe for steel. It is almost equally strong. So, what is the reason means I will tell in the steel class why FCD used. But when you use FCD, tension side, what happens, that all we will discuss here. So at that time, in the steel class, I will tell, if you got any further clarification about stress distribution, refer to YouTube class, playlist is what? Bending and shear stresses. Go through everything. Those who are serious will go through. Okay, now, come here. This is the cross section given. See, all dimension millimeter. Last time I told you to locate center of gravity or to locate neutral axis. Actually, we don't want center of gravity. We want to locate neutral axis. But we know that neutral axis passes through CG. So, locating neutral axis is nothing but locating CG if we are considering within elastic, in the elastic theory. Whereas, locating neutral axis in plastic theory is not CG. Anybody know the answer? Neutral axis for plastic theory will not be through CG. Anybody can tell? Where is it? If you know it, tell me. Otherwise, I don't know. If it is plastic theory, that is when plastic suction modulus collapse mechanism is considered, at that time, neutral axis will not be through CG. Theory is there. In steel, you will get it. Anybody can tell if you know it. At that time, it is not through CG. It will be through. If you don't know, tell fast, don't know. Always when I ask a question, tell the answer immediately. So that I don't, I am trying to get the answer if possible. In case you know the answer, let me know. In plastic theory, see, no response. You either tell the answer or tell don't know. Don't hesitate, tell don't know. In front of me, telling don't know is no problem. Some will tell, oh, as if he is knowing everything. Yes, I know everything only. Don't know. There, it is passes through the neutral axis, will divide the cross section into two equal areas. That's why plastic neutral axis is also called as equal area axis. Heard of it at least, tell me. At least heard of it. It is also called as equal area axis. At least in somewhere in B, heard it. Equal area axis. Then ZP equal to A by 2 into Y1 bar plus Y2 bar. There also Z theory comes. Okay, now, in this chapter, we discuss only elastic behavior. See, start. We want to locate CG. Note, first locate neutral axis which passes through CG of cross section. Then find moment of inertia of cross section about neutral axis. Why? Because reason. When you apply that principle M by I equal to sigma by Y, Y is from neutral axis. I is moment of inertia about neutral axis. About neutral axis. Some will tell, sir, suppose use Z concept. Oh, then neutral axis not required. Very good answer. Okay, tell me, formula for Z. Z is required, I by Y. Z is I by Y. Once again, same. So whether you use Z concept or basic equation, moment of inertia is required. Some will tell, sir, rectangle section, we don't require. Why? Sir, BD square by 6. How you got it? Sir, that is BD cube by 2. Oh, yeah, sorry, sir. Sorry. There also you require. Because there also I equal to BD cube by 12, Y equal to D by 2. When you divide, then you get Z equal to BD square by 6. Not from nowhere it came. It came from basic moment of inertia principle only. So, any bending stress chapter you require where is CG and moment of inertia about neutral axis. Now see, only once I will explain moment of inertia, CG and moment of inertia. I told last time. Majority, so actually this course is for BSK batch. BSK batch, this is already over. In engineering mechanics, moment of inertia so thoroughly over. But still, since it is the general public, someone may comment later. He told all the concepts, but moment of inertia, he has not told us. Why should I tell it? You should know it. We are not knowing. Then study yourself. But still, instead of being so harsh, I decided, okay, at least one critical example explain. From today onwards, Moment of inertia is your problem, not my problem. Any example I take, I will write directly, CG is here, moment of inertia is this much. Go and get it later. This is for unsymmetrical I section. Suppose symmetrical I section, it is very easy. That briefly I will tell here. Start. Now, write something I am writing here. What all I write here? See, this is rough cross section given. See, no dividing into parts. You can see here solid junction. See, this is monolithic. Dividing line is not there. Dividing line you are putting for calculation purpose. Nowhere you can see I section like this. Actually, steel you can see, then it will be properly welded. So this become rigid here. Or you consider monolithic only. Okay, now that's why when bending takes place, that connecting welds, you have to design for the sliding force. So if the sliding force is resisted by welds, then only you can consider section to be like this. Otherwise, these three will behave like three independent beams placed one above other one. See, placed one above other one. No single section. Okay, now that all steel part. Now, I am telling something here. I wrote something. First, write the cross section neatly, as neat as possible. Somewhat scale. See, 300, 250. Relative scale. Don't measure and tell me. Okay, now 20, 30. This is 12. Mark all component CGs. See, CG for this rectangle, CG for this rectangle, CG for this rectangle. We need only x-axis axis. If you need x-axis axis, you require vertical. See, to locate any horizontal axis, you require vertical distance. So, to locate CG, you find a term called Y bar. Y bar you can find either from top or bottom. Long back, I was always finding from top. But nowadays, because of the software, where Y is upward positive, so therefore, I decided to find Y bar from bottom edge. See, this is the reference line for Y bar. From here, you are measuring Y, and also from here, you are getting your Y bar. From here, Y bar is red color. Why? Because it is important. Okay, yes, right time. Red color or not? Where is red color? Nice. See, Y bar is red color. I'll put Y bar. Start. Formula for Y bar: A1 Y1, A2 Y2, A3 Y3 divided by total area. Or technically, if you talk, it is means Y bar is equal. See, moment of the entire area about any reference axis, that is total area. See here, total area into Y bar equal to sum of moment of the component areas about the same axis. See, A1 Y1, A2 Y2, A3 Y3 will be equal to total area into Y bar. That is the principle, not simply formula. People ask, what is Y bar formula? A1 Y1, A2 Y2, A3 by 3 by, they will tell A1 plus A2 plus A3. A1 plus A2 plus A3 only is area only. A1 plus A2 plus A3. Okay. How you got it? No, sir, formula. How you got it? Sir, formula. What formula? It is a principled one. Start. Start from here. Area of this rectangle, 250 into 30. I wrote there. This area into its center of gravity distance of CG of that rectangle from here. This is 30. 30 by 2. That will give you A1 Y1 plus second area 12 into 350. It is there into its CG from the bottom reference line is 30 plus another 350 by 2. Okay, plus 300 into 20 is next area into 30 plus 350 plus another half of 20. Or you can do one thing directly from 400 subtract half of 20. Anything will do. Divide by A1 plus A2 plus A3 will give Y bar. I think Y bar you got 212.8. Correct answer? 80 came. 212.80. Is it correct? I noted down somewhere there. Why? I saw the recording I saw the last time class video there. Actually not video. I never call anything as video. It is not entertainment video. I call class, but YouTube calls it video. What to do? I can't type class there. I type video. YouTube video, if I type, video will come. If I type YouTube class, it will give something else. YouTube is fully commercialized. Yes. Tell correctly. 212.8 mm. Over. Now, note, go back and mark neutral axis as per this calculation. Now, something I am telling in the class, you write it. I am telling something in the class right here. Before marking start, from here to here is 30. How much you have to go? 212. Further you have to go. Here to here is 30. Here to here will be half of 350. So, this CG of the second rectangle, middle rectangle, from here will be 30 plus 175. Tell the answer. This CG, it is very important. This CG from here will be 30 plus 175. What is the answer? 30 plus 175. Answer fast. Don't waste time. 30 plus 175. If you delay means, I know it is 205. You should tell it. Then only you are involved in the class. Some will tell, sir, you don't know that much. I don't know that much. I don't know how to add. 30 plus 175. How much answer? If you don't answer, class I am closing. When I don't get reply, class will be closed. Some will tell, you know the answer. I know it. Tell it. Reason to confirm that what? Ever is fully audible. Two reasons are there. One reason is you should get involvement. You should have involvement. Second one, I should confirm that everything is audible. No, if you are delaying this way and so many are absent today, very few present, at least 1% sufficient for me. The one who usually answers, they are absent today. Both of them are absent. That's why delayed. At least those who are here, tell the answer. 30 plus 175. Unless you tell, I won't continue. See, you are wasting unnecessary time. If you don't tell, it means some audio problem. Some audio problem is, I cannot conduct the class. I will wait. 205. Tell that way. 205. Okay, then from here to here is 205. But our y bar from bottom came 212.8. So it will go slightly above. See, it will come somewhere here. Very, very important. Slightly above. So this is your neutral axis. You can also call as x-x axis. Usually call neutral axis only or x-x. Okay, now correctly mark here. From here to here, this distance, we got 212.880 not required, calculated value. Then immediately from 400, see right here, locate the neutral axis as per calculation. Since you calculate from bottom edge, first observe where correctly it will come. Don't write somewhere here. Why? This is 205. It will overtake that one. Then immediately write the value from other side. Answer fast. This is this distance. From 400, subtract this one and write this answer. How much? From 400, subtract this one and write the answer. I can see it there. I can see the answer there. I noted down. How much? From 400, subtract it. You have to give the answer immediately. 187.2 millimeter. Okay. This is, remember, 187. This is by calculation. I will double round off. Double round off means by using this value I got it. Okay. Now, over. Neutral axis located. Now, make a note. By chance you get less than 205, your axis will be somewhere here. Be careful. It will not come to midpoint. It will be slightly down. That's required when you find moment of inertia. Okay. Now, note, those who want, if somebody wants, make a note. Instead of y bar from bottom, you can find y bar from top also. No problem. You do it. Right. Formula. A1, Y1, A2, Y2, A3, Y3 by total area. Now you take distance from top edge. I'll start from here. See, 300 into 20 into half of 20. 12 into 350 into 20 plus half of 350. Don't see this axis. Complete blank. Plus 250 into 30 into 20 plus 350 plus half of 30, or from 400 subtract 30 by 2 divided by A1 plus A2 plus A3. You will 100% get same 187.2. Then this you got. From 400 subtract, get this distance. So you find y bar either from bottom edge or from top edge. Your choice. Now onwards, I will not talk about y bar in the class. Fully clear? Now onwards, regarding this location of neutral axis, I will not talk in the class. Full clear? I will not talk about it. Directly mark it. There is a limit for explaining, because this class is bending stress chapter, not CGMI. Those who are studying all the subject concept, they should understand the basic calculation. It is their responsibility. If I go to CGMI, someone will tell, you prove it then. Okay. Now, everything I am removing now, CG is located. Now see, correctly next step. Go for moment of inertia calculation. Now go for calculation of moment of inertia of entire cross section about neutral axis. That is I about neutral axis. Now see, 1 minute. If you see the neutral axis, our I section, we divide it into 3. All this you have to write. Those who want should write. Our I section, we divide it into 3 parts. And each and every part has its own CG. CG here, CG here, and CG here. Now, for a rectangle, for moment of inertia, you know the formula for about centroidal axis, that is BD cube by 12. B is the parallel side, about which axis you calculate, axis parallel, side parallel to it. See, if I want moment of inertia about this axis, it is this width parallel side into this cube. If I want about this axis, it is parallel side is here, this side into this cube by 12. But that is moment of inertia about axis passing through CG of each and every component. But unfortunately, we do not want I about this axis, or I about this axis, or I about this axis. We want I of the entire cross section about neutral axis. Therefore, write, since center of gravity of each component lies outside neutral axis, to get I about neutral axis, use, tell me, what theorem? Fast. Use what theorem? Tell fast. Too much I will not explain. Actually explaining too much only. Use what theorem? Some theorem is there. If you want to locate I about any axis which is not passing to CG, then use what theorem? Some name. There is a theorem name. Some theorem you have to use. Using that you can find I. Don't tell don't know. If you tell don't know, I have to close the class. Use which theorem? There is a theorem used. Those who are answering, use parallel axis theorem right here. Use parallel axis theorem. Parallel axis theorem. According to parallax theorem, I about any axis equal to Ig plus small a into h square. That way you have to go for summation. Each part you consider separately, then find I about its own centroidal axis. Area of right here, Ig is what? I about its own centroidal axis. Axis passing through its own CG. A is the area of that component. H is perpendicular distance from CG of the component considered to that axis about which you want moment of inertia. We want moment of inertia about neutral axis. So now H should be from neutral axis. Over. Start. That's all. I think I am giving much more than required. So I about neutral axis. It should be red color. See, neutral axis red color. Equal to, start here. Come to this rectangle. If you want I about this axis, see, for this rectangle, this is outside axis. First come to its own centroidal axis. See here. Axis passing through CG of the component, but parallel to this axis, not this way. If you want this way, parallel here. Write I about this axis. This is rectangle B into D cube by 12, that is 300 into 20 cube divided by 12. That is your IG plus area. That will give you I about this axis. But we want I about this axis. So plus area. 300 into 20 is the area into from CG of the component, from this axis to this axis, perpendicular square, this square. That is 187.2 minus half of 20. 187.2 minus 20 by 2, don't forget square. This will give you moment of inertia about neutral axis for the uppermost rectangle. Start. Plus. Start here. Come to this rectangle. This rectangle. Its CG is here. So don't see neutral axis now. First about its own axis. See here. Its own centroidal axis here. Parallel side is 12. So 12 into perpendicular is 350. 350 cube divided by 12. This 12 is width 12. This is standard 12. Okay. Plus area. 12 into 350 is the area into CG of the component to this axis, this distance square. See here. This is, see here. If I want this distance, come this side. Suppose axis comes here, go that side. That all, if I keep on telling, it will become moment of inertia class. Once you understand this one, in the next question, I will see that CG will come, see this will come somewhere here. Then you should go upper side and do it. Make a note. Okay, start. From 212.8, from 212.8, I want this distance. Subtract this distance. See, I want this distance. 212.8 minus 30 minus half of 350. Minus 30 minus 350 by 2. That number whole square. This will give I about neutral axis of the middle portion. Start. Last one. Its own CG is here. I about its own axis. 250 into 30 cube by 12. 250 into 30 cube by 12. IG over. Plus area. 250 into 30 is the area into from CG of the component to the required axis. This distance square is 212.8. 212.8 minus half of 30. 30 by 2 whole square. That's all. I think last time I noted the answer 514.132 10 to the power 6 millimeter power 4 is the answer. I noted down from the class. From the class I noted down. I went to the previous class, moved it. When I reached the end of that one, took a screenshot, and in the other mobile, I transferred it, seeing that I wrote the answer. Because I only calculated. Correct answer? Now if you tell, I will close the class. Sorry. Now if I am going to close the class. Now I am not continuing. I am not going to continue the class. Sorry. I asked you 2-3 times. Is 212.8 is from bottom edge or top edge? I told from bottom edge. That means You are not serious in learning. Very sorry. I am going to stop the class now. Restart tomorrow once again. Penalty. This will be there permanent in YouTube. People should know how harsh I will become. I told you last time, calculate and make a note. And even now, I wrote the steps for you, Y bar. And now you are telling it is 187.2 from the bottom of 250 mm. I will not continue the class. Sorry. If it is wrong, I cannot continue. I will restart tomorrow. Today's class gone. One class gone. Penalty. People should know it. Involvement required from people. I take this much trouble and explain so many concepts. Not for fun. This can be finished in 5 minutes only. No, sorry. I asked earlier. You told yes. I told Y bar I got 212.8. You agreed that it is correct. You agreed that it is correct. Now if you tell after the when, if you had told earlier I agreed. See, 205. You told everything clear, Parallax Theorem, then 187.2, when I wrote 212.8 from here, I asked you how much from here. You told from 400, subtract and get the answer. You should have told at least at that time. I will just check it now. I am going to check it now. If the answer is what? If the answer is interchange, I will continue the class tomorrow. I cannot repair today. No, it is a penalty. Okay, one class gone. What I will do tomorrow is, I will write 212 there, then CG will come here. See, it will come where? It will come slightly below this one. And then my moment of inertia will be on the other side. So therefore, people will watch. I will calculate now and check. That's, see, I am not going to anything now. Silently I am going there if it is wrong. 250, I will calculate once again. 250 into 30 into 15 plus 12 into 350 into 30 plus 250 by 350 by 2. 350 by 2 plus 300 into 20 into 400 minus 10 divided by 250 into 30 plus 12 into 350 plus 300 into 20. I got 187.2 from bottom. That's all. This class will remain in the YouTube. I am not going to delete it. I am not going to delete it. Those who are watching this class, in future remember, if involvement is not there, if you don't show involvement, simply blindly accept the answer, what happens? I am taking this much struggling and explanation. I would have told so many principles today about what bending, allowed stress in the top, allowed in the bottom, RCC link, steel link, all would have come. When you find moment of resistance, how to control the stresses, for especially when stresses, strength is different in tension and compression. Very important for RCC, very important for steel, and also this one. If it is symmetrical, no difficulty. It is a master question. Sorry, nothing can be done. Let the people understand. In future, it's coming 187.2.